Good morning, everyone. We are going to continue with Module 5, Lesson 27, where we compare fractions that are going to be greater than 1 using our greater than, less than, or equal to symbols. I want us to first begin by reminding us that we're going to be going over 3 ways, and there are 3 ways to do this. There is the tape diagram, the area model, and also standard algorithm. We are going to be working today mainly with area model and standard algorithm. We're first going to start with area model. I want you to copy these 2 fractions down or mixed numbers down, 3 1/3, and we are going to be comparing that with 3 2/5. 3 1/3 and 3 2/5. So as we notice, these 2 fractions have the same whole number of 3. 3 and 3. So what we want to be comparing today is the 1/3 with the 2/5. Since they have different denominators and one can't go in the other, we want to make sure that they have a common denominator that both of these numbers can go into. So I want you to be thinking of what might a common denominator between these 2 numbers be. Take a moment, and while you're doing that, I'm going to be labeling our 1/3 and our 2/5. So in this area model, we have split it into 3 pieces and one of them is filled out. We have split the second area model into 5 pieces and 2 of them are filled out. So you may have found that the common denominator is going to be 15 because both of these numbers are able to go into 15. So what we want to see is what we have to multiply with 1/3 in order to receive that common denominator of 15. So let's start with 1/3, and what do we want to multiply with 1/3 in order to receive 15? Yes, we're going to multiply it with 5/5, giving us the fraction 5/15. Now we know that we are able to label our area model by splitting our area model into fifths, or 5 parts. So we're going to make 1, 2, 3, 4, and 5. And now we have 5 out of the 15 boxes filled out. Similarly, with this second one, what do we want to multiply with 2/5 in order to receive that denominator of 15? Yes, we want to multiply with 3/3 because we know that 5 times 3 will always give us 15. So that gives us the product of 6/15, and now we're able to split our area model into thirds. So we see that 6 out of the 15 boxes are filled out. So now that we have that same denominator or that common denominator, we are able to compare. I see that 6/15 carries more weight than 5/15. So that means that 3 1/3 is going to be less than 3 2/5. Remember that 2/5 is the same as 6/15 because we just decomposed it by thirds. And 1/3 is the same as 5/15 because we decomposed it by fifths. Finding that common denominator between the 2 fractions gave us the tools to show in our area model which one has greater value. So the next 2 numbers that we are going to be comparing is going to be 10/3 with 10/4. And for this one, we're going to be using standard algorithm. Differently from our previous question, we noticed that these are going to be improper fractions. So what we need to do is we need to convert them to a mixed number in order to see which one might have more weight or carry a larger value. So let's first start by converting this first mixed improper fraction to a mixed number, 10/3. By doing that, we need to see how many times 3 can go into 10. So I want you to skip count. How many times can 3 go into 10? Yes, 3 can go into 10 3 times. 3 times 3 equals 9, giving us the product of 9/3. So what is left over when we take 9/3 from 10/3? Yes, we have 1/3 left over. Okay, so we know that this is going to equal a whole number because 9 can be divided perfectly by 3. When we convert 9/3 to a mixed number, you can divide your numerator by your denominator. 9 divided by 3 gives us the whole number of 3, and we have 1/3 left over. So we know that 10 and 10/3 is going to be equal to the same value as 3 and 3/3, or 3 and 1/3. So now that we have this mixed number, we're able to compare it with 10/4 once we convert 10/4 to a mixed number. So we want to first begin by seeing how many times 4 can go into 10. Take a skip count. Yes, 4 can go into 10 twice. 4 times 2 gives us 8, making our first fraction 8/4. When we take 8/4 from 10/4, we are left over with 2/4. Now that I have this information, I'm able to convert 8/4 to a whole number. 8 divided by 4 is going to give us the whole number of 2. Great. And we have the leftover of 2/4, meaning that 10/4 is equal to the mixed number 2 and 2/4. So now that we have this information, we are able to just compare them because they have different whole numbers. So remember, when they have different whole numbers, we can see which one has greater value with the fraction or the mixed number that has the larger whole number. In this mixed number, we see that 3 and 1/3 is going to be greater than 2 and 2/4, because 3 is always going to be greater than 2, no matter what their fraction is. The next question we are going to use standard algorithm for is by comparing the two fractions 12/4 with 10/3. That's 12/4 with 10/3. So again, like our last question, we need to convert our 12/4 and 10/3 to mixed numbers so that we're able to compare them. We're going to first start by looking at 12/4. And in doing so, we want to see how many times 4 can go into 12. Great, 4 can go into 12 exactly 3 times. So it's going to be a perfect whole number, and that perfect whole number is going to be 3. I know that 4 times 3 is going to give me that numerator of 12, and I know that 12 divided by 4 is always going to give me that quotient of 3, meaning that this whole number of 3 is always going to be equal to the fraction 12/4. Now we want to do the same thing with 10/3. How many times can 3 go into 10? Yes, 3 can go into 10 3 times, giving us the fraction 9/3. When we take away 9/3 from 10/3, we are left over with 1/3. So now that we have this information, we're able to convert 9/3 to a whole number. And 9/3 in a whole number is going to be 3, because I know that 9 divided by 3 is 3, and 3 times 3 is 9. So you can always work backwards and always work using multiplication and division to solve for that. We have 1/3 left over, giving us the fraction and mixed number 3 and 1/3. So now that I have this information, I'm able to compare. I'm just going to write the 3 down here so it's on the same line as 3 and 1/3. I'm able to compare the fraction 3 and 3 and 1/3. So we might notice that both of these have a whole number that's the same. They both have 3 wholes. However, this one has an extra 1/3 attached to it, meaning that it has a little more value because it has that 1/3. So I know from that information that 3 is going to be less than 3 and 1/3. Similarly, using our improper fractions that we began with, 12/4 is going to be less than 10/3. The last question we are going to go over today is going to be using the area model, but we're going to also have an improper fraction with it. So what we see is we are going to be comparing 16/5 with 3 and 2/10. And since we have one mixed number and one improper fraction, we need to both get them on the same level. So we want them to both be mixed numbers so we're able to start comparing. So let's first start by converting our 16/5 to a mixed number. How many times can 5 go into 16? Yes, 5 can go into 16 exactly 3 times, giving us the fraction 15/5. What is left over when we take 15/5 from 16/5? Yes, we have 1/5. Okay, so now we're able to convert 15/5 to a whole number. 15 divided by 5 is going to give us the whole number of 3. So I have 3 and 1/5. So now that I have the mixed number 3 and 1/5, I'm able to compare that with the mixed number 3 and 2/10. So what you might notice between these two fractions is that they have the same whole number. So what we want to compare them with is the fraction. They have different denominators in this fraction. Our first fraction has 1/5 and our second fraction has 2/10, meaning the denominator here is 5 and the denominator here is 10. So what we want to do is we want to use an area model to help us solve for a common denominator. I'm going to first start by making our area model of 1/5. We want to split it into 5 parts. And we want one of the 5 parts to be filled out. Because remember, we're not comparing the whole numbers anymore, we're comparing the fractions. On this side, 2 out of the 10 pieces are going to be filled out. 3, 4, 5, 6, 7, 8, 9, 10. So because we know that 5 can go into 10, we only need to decompose one of our fractions. We don't have to decompose both of them. We only have to decompose the 1/5 because we want to have that matching denominator of 10. 5 can go into 10 exactly 2 times, so we're able to use that multiplication, 1/5 times 2 over 2, giving us the fraction 2/10. I'm able to split my area model in half, proving and showing that I have 2 out of the 10 boxes filled out. So we show here that 2 out of the 10 boxes are filled out once we have decomposed, giving us the fraction 2/10. We are comparing it, though, with the fraction that we started with on this side, which is 2/10. 2/10 has the same value as 2/10, and we show that in our area model. So if these two have the same value once they have a common denominator, we know that these mixed numbers are going to be equal to each other. 3 and 1/5 is going to be equal to 3 and 2/10 because once we decompose them, they carry the same value. So we're able to translate that to the numbers we began with. 16/5 is going to be equal to 3 and 2/10. I hope you have a wonderful Tuesday, 4th grade. Keep up the awesome work. You are all doing great. Bye-bye.